All right, so today we'll just start getting into kind of Python programming concepts. This is real basic stuff today, um, and I know you guys took Stats 20, so you're already familiar with a lot of these ideas, but we got to kind of mention how they work for Python because there's a lot of similarities, but a few differences that are important, and so we'll talk about that. Okay, again, so all of my notes, all of the stuff is going to get posted to GitHub rather than CCLE. Oh, you know what? What I do need to do on CCLE is I need to activate our view quiz. I have to make that visible. Okay, so the view quizzes, those will still be on CCLE, and I'll still post YouTube links on CCLE for the lectures. But all of the notes are going to be put on GitHub. And so, sorry, let me log in via Duo. Come on. Oh, here we go. All right. Okay. So let me just turn on our view quiz for today. All right, I might as well give you your first view quiz answer while it's at the forefront of my mind. First view quiz answer today is the letter A as in apple. And I just made it visible. So if you've been wondering where is it, it was hidden, and I just made it visible on CCLE. So you should be able to see it now. First view quiz answer is A as in apple. Okay, and again, all of the lecture notes are posted on GitHub. So I've already done it on my computer, so it'll say it's already up to date. But you will first you have to change into whichever directory you have your stuff. And so for me, it's in my home directory. But navigate to wherever you are, and then you can always do git status. But what I'm going to do is I'm going to do git pull upstream main, and that should do it. And you should have lecture 2-1. So 2-1 lecture stats 21. Okay, I hope this GitHub stuff is working for you guys. I think GitHub is so great. Okay? And anytime you start anything new, it's a little bit awkward and it feels a little bit strange. But I think just the fact that you can just type in git pull and it's going to get everything new, that's hard to beat, right? It just stores it all onto your local machine. Okay. Anyway, today's lecture has been posted. It is we're going to just take a look at basic data types. So let's go ahead and take a look. All right. Okay. So right now we're talking about base Python. Other data structures do exist, and they are important, such as the array and things like that from NumPy and the data frame from pandas. Those are very important, but you have to load libraries to get those to work. And so we're going to just start with kind of the ones that exist in base Python, the ones that don't require external libraries. And so you have this basic data types, which will be your strings, your integers, your floats, your Booleans, and the none type. There's also a complex, but I'm going to just kind of ignore that for now. Okay. So anyway, these are going to be the ones that we commonly use. If you're coming from R, these are a little. Some of the names are similar but different, right? So in R, we called string data was called character data, and then floats were called type double, and Booleans were called logical and things like that. But here, these are the types: strings, integers, floats, Booleans, and then none type is kind of what's used to refer to like null values and stuff like that. Okay, Python has some very important data structures, and we will cover those in a future lecture. And those include things like lists, tuples, and ranges, dictionaries. You got sets, and you have binaries. Okay, but we'll take a look at kind of these values and things like that. All right, so if you have anything in quotes, that's a string. Okay, so even though this looks like the number 2, it's in quotes, so that's a string. The number 2 itself is an integer. And if you have 2.0, that's going to be a float. All right. So that's pretty straightforward. True is a Boolean. Okay. True is spelled with a capital T, lowercase R-U-E. And then none, capital N, lowercase O-N-E, none is always a reserved word, and that's the none type. And so you can find out what type of value it is using the type function. And we have that. Okay. All right. We've got a few basic math operations. These are kind of the math operations that exist in base Python. If you want to expand, if there's like a math operation you want to do, and it's not listed here, you probably have to import a package like math or NumPy or something like that. Okay. So, you know, addition, multiplication, subtraction, division. This is integer floor division. This is modulo for getting the remainder. Okay. And then star star is exponentiation. And then the absolute value function as well. And so those exist in base Python. So anytime you add integers together, the result is always going to be an integer. So here I have x equals 10, y equals 5. These are both integers. So I can say, you know, what's the type of x and what's the type of y? And it tells me that it is class integer. And here, if I take x plus y and I set that equal to z, I ask what is the type of z? Z is also an integer. Okay. So notice I do want to point something out here. This is just something that happens with IPython. Here, because I told it to print, it prints it out here, and it comes out as this this object. It prints out this thing that says class int. But you'll notice that there's no out. There's no out6 because here I use the function print, right? And so one thing about Jupyter is that every cell can only have one output, right? And so if you have multiple things, if I did type X followed by type Y, it would only show the result of the last one, which would be type Y, and it would show int here, but we wouldn't be able to see type X. So if you want to see multiple results, you got to use print, but then print returns a none. Okay, it doesn't actually return a value. You can't, like if I tried to store or save the result of print, it's going to store a none. Okay, so anyway, that's why you see print here, and then here you can just do type Z, and there is an output associated with this cell. Okay, so anyway, that's an integer, and Z is 15. Okay, sorry, let me check on my dog. I don't know why. I feel like at 5 o'clock he knows to start barking to to be maybe he just doesn't like the fact that I'm talking to a computer or something. I don't know. But okay, so anyway, so that's that, right? Add integers together, you get an integer. That shouldn't be a surprise, okay? You multiply integers together, you also get an integer, right? So x times y, those are both integers. You multiply those together and you get the number 50, okay? Also an integer. Okay, well, if you do division, so if I do 10 divided by 5, the result is always going to be a float, okay? It's always going to be a float. So even though 10 divides by 5 evenly, and the result, you know, in terms of real numbers is an integer, computationally, division will always result with a floating point number, okay? And so a thing about Python is you can easily distinguish between an integer and a float just by its appearance, because floating point numbers will always have a decimal. So even though it's the number 2, just to kind of indicate to the user that this is stored as a float, it's going to print out as 2.0. Okay, it's going to be printed out as 2.0. So if you see that decimal there, you know that it's a float. Okay, and if you don't see the decimal, such as back here, like the number 50, you know that it's an integer. So that's a nice feature of Python that I wish R had, but alas, you just kind of have to assume everything is typed double. Okay, and the sum or product of integers will float, or with a float will always result in a float. So so if you do 10.0, so the fact that I've written 10.0 as a 10.0 here means that this is going to be a float. X is going to be a type float, and y is going to be integer. And if I multiply those two together or add those two together, I'm going to get 15.0, which is a float. Multiply them together, you get 50.0, which is also a float. Okay. So in the computer, and if you took 102A with me, we covered floating point things. But if you haven't taken 102A or something, this is just a very, very quick overview of floating point types. Okay, and a floating point number uses 64 bits to represent decimal values, and so you can represent a lot of values, on the order of 2 to the 63 different kind of distinct values and things like that. But there's only only a finite number of distinct values that you can represent, which is not going to be sufficient for the real number line. And this corresponds to approximately 16 places of precision, okay, in the decimal system, around 16. And the maximum value is this and things like that. Okay. So with a floating point number, I can do 2.0 raised to the 1023, and we can represent that. If I do sum 2.0, 10 to the 23, 10 to the 22, and 10 to the 21, I get something starting to approach this. Okay. If I do try to do something like 2.0 to the 1024, this is too big to be represented as a floating point number. Okay, and so you get an overflow error, right? It says the bottom part of the message doesn't show up here, but it says overflow. Basically, we can't represent this number here. Okay. One thing to note is that floating point numbers don't work the same way that real numbers do. All right. So here I have a is equal to 1 plus 2 divided by 10, and b is equal to 1 over 10 plus 2 over 10, which, with real numbers, we know these two things are exactly equal, right? This is 3/10 and this is 3/10, and these two things should be exactly equal. But because these are stored with floating point numbers, just, mathematical properties like association or associativity or, the order of operations can actually affect the result. And so in Python, if you say, is A equal to B, all right, if A is equal to B, this is a test for equality. Equals is you're asking, is the value A equal to the value B? It comes back as false. It comes back as false, right? And that seems strange. And the answer is revealed if you format the number so that it prints out, about 20 places, 20 decimal places. Okay. And so this is, I haven't gotten into it, but this is how you can kind of format numbers here. And so here it says, I want 20 spaces after the decimal point. This is like a whole nother lesson here, but just this is a quick way to say I want 20 places after the decimal. And we can see A gets stored as 0.299998890, which is close to 0.3, but not exactly 0.3. And the value B is 0.3000, ending with 441. And these two things are both close to 0.3, but not exactly 0.3. And that's just a limitation of floating point numbers. And so in Python, there is a function called isClose. Okay. And again, that's in the math library, and we're going to, and you can load that up by calling import math, and you can say, are A and B close to each other? Is A close to B? And that's going to come back as true. Okay. And, there's obviously limitations here, but, basically, the bottom line is when you're dealing with floating point numbers, don't rely on floating point numbers to check for exact equality. Okay, I apologize. My dog is demanding my attention again. So give me a second here. I apologize. Okay. All right. I love my dog. He's really good. I just don't know why during class time he wants to cause a scene here. Okay. So integers in Python use a variable amount of memory. And so you can store very large numbers with great precision in Python. So here you can say, take the integer 2, raise it to the 1023rd power, and it lists off all the places, okay? And so, you know, this actually takes up a fair amount of memory in your computer, but I mean, it's not like you're gonna run out of space. You probably have like 8 gigabytes or something. And so this is not a big deal, okay? And so you can take things and say like, raise it to the 1024 power, and it does, okay? And raise it to the 10, and so with integers, you can get really big numbers, okay? And so you're not limited to using only 64 bits of precision, and it can do stuff like this. All right, exponentiation. I don't think I need to explain too much. So exponentiation can return an integer or a float depending on the input. So here I did 9 to the 2nd power, and it gives me back 81. There's no square root function in base Python, okay? There is a square root function if you load the math library, but in base Python, there's no square root function. You can, you know, there's a workaround. You can just raise things to the 1/2 power, and that also works, okay? If you do want to do something like a square root, you got to load the math library. And so a lot of things that you might expect to exist in Python, in base Python, just don't. So for example, constants like pi or the exponentiation function or any kind of trig functions, these things come back and they just say, these things aren't defined, okay? These are not. I want you guys to also become accustomed to reading Python errors. Most of the Python errors are actually helpful, okay? And they're not just mysterious if you read them. So here it says, it comes back with a name error. And basically that means you're referring to some kind of value that just doesn't exist in the workspace here. Okay, so there is a library called math or package or module, and I use kind of these things all interchangeably. The NumPy library also includes a lot of these functions. So you don't, if you load NumPy, you probably don't have to load math and things like that. But so if you import math within the math library, there's a square root function. And so the way you would reference that, it would be math.square root. And you can do that. Math.pi gives you the value there. Math.exponent gives you this, and things like that, okay? The trig functions in math use radians. So if we say, you know, what's the sign of pi over 2? You know, it comes back and says that's 1, all right? And again, you have to kind of, if you just used sign, okay, without saying math dot, it's going to complain and say that thing doesn't exist, okay? So sign exists under the math library, and you reference it using math dot, whatever name the function is. All right, so Booleans are used to express true or false values, and this is how we pretty much do all of our kind of conditional flow as far as functions and programming goes, right? You know, if this, you know, if this is true or if this is false, you know, if I should say, if this is true, then do the following actions, and when it's false, you don't, right? And so, so that's Booleans. And so as far as Boolean values go, it's only capital TRUE without any quotes, and this is a reserved word in Python. And so, so that's always going to be associated to the Boolean value, right? If you put true in strings, it's going to just keep it as a string, right? And this is the only accepted spellings for true and false. Okay, any other spellings? So if you try using all caps true or capital T or lowercase t or lowercase true or things like that, you're going to get a name error. It's going to say this thing doesn't exist. Okay, these things are not defined. So, so always use it capital T, lowercase RUE, capital F, lowercase false, and lowercase ALSE. That's when I've switched between R and Python, because R is always all caps true and R is all caps false. This is a thing that I often get tripped up on. So just keep that in mind. Okay, strings, I think strings are really fascinating in Python. And so we're going to actually have dedicate a lot more lecture time to the topic of strings a little bit later. But just for now, you know, you can use double quotes or single quotes to define a string. Okay, and then there's a few functions that that work on strings, such as the len function for the length of the string. Okay, and you can also use and I think I showed you this just very briefly on, say, on Friday's lecture, where you can use multiplication with a string, and it's going to just kind of concatenate a bunch of the strings together. Okay, but strings pretty cool. They're treated almost like lists in Python, and we'll take a look at that in a future lecture. All right, let's talk about variables in Python. Okay, so as far as assignment goes, we just use the equal sign. Okay, so we just say, all right, take this value and set it equal to or basically associate this name to the value that we see here. All right, actually, let me give you your second quiz answer for today. Second quiz answer for today is D. D as in dog. D as in dog. Yes. Okay. D as in dog is your second quiz answer. And so, so as far as variables and assignment goes, the name that you're using as the variable always has to be on the left-hand side of the equal sign. Okay. And this this updates whatever's on the left with the value on the right. Okay. Okay, and then the value being assigned must be on the right-hand side. All right, and when you do an assignment operation in Python, you're not going to see anything outputted or updated onto the screen. It doesn't return a value when you do this. Okay, so if you just do n equals 5, all right, it's going to take the value 5 and associate the variable name n with the value 5, and that's it. Okay, there's no output to go with this. Okay, so later on you can say, all right, what is the value of n? You can say print n, and it's going to come back and it's going to say, you know, the value there is 5. Okay, but there's no out here. There's, you know, print doesn't actually return anything either, so there's no output here. There's no out 48 or anything like that, but it does print the value out onto the screen. Okay, so in Python, and this is similar to the way R works, is that the names in Python are all pointers. Okay, they so if you've taken another language, such as if you've learned like C++ or Java or something like that, when you define a variable, you're effectively defining a container or a bucket in memory that's going to store a certain type of value. So you declare your variables. You say something like, I'm going to create an integer called x, and inside x store the value 4 or something, right? That's something you might do in C. Okay, and basically this says, you know, this bucket is only going to be allowed to hold integer values, and so anytime you put something else in, it's either going to try to convert truncate it down to an integer, right? If you do some kind of operation, or it's going to result in some kind of error, right? Whereas in Python, when you write something like x equal to 4, you're creating a pointer. You're just going to take the name x, and it's going to point to a different bucket, okay, a different bucket in memory, and that bucket stores the value 4, okay? And so in Python, you don't have to declare variables, right? And basically, you can just have that pointer point to a different value in memory, all right, of a completely different type, All right. And so, so we say Python is dynamically typed. Okay. It's not strict, and it's not saying like, oh, here you said X started off as an integer, so it has to stay an integer. No, you can start off with X as an integer and then easily point it to somewhere else that has a string value, and then point it later on, point it somewhere else that stores a list or something like that, right? All of these things exist in memory as some kind of object or a value, and we're just associating the name X, okay? And Python does its own, what we call garbage collection, where, once it realizes that nothing is pointing to a certain value, it throws that value out. There's a garbage collector that does the cleanup, okay? You don't have to worry about it, okay? All you have to, at the end of the day, I guess all I'm saying is that Python makes our life easy in that we can switch types, not worry about it. Okay, so here I do want to take a moment and talk about how we are going to name our variables, okay? And so you can name your variables almost anything, okay? I mean, of course, there's limitations, right? So names can have letters, numbers, and underscore characters. Names can't start with a number, okay? And you can't have other symbols other than underscore, all right? You can't have spaces in your name, and your names can't be a Python keyword, right? So here is a list of all of your Python keywords, okay? So these things are reserved, these serve important functions. So things like false, none, and true are Python keywords. Those are the only keywords that have a capital letter, okay? And then everything else is kind of, I think, we're expecting these, right? If and else and for and things like that, okay? While, raise, and so pretty much everything else, you can create a name, a variable, name that thing. Now, some of them, other things, there are important functions that you shouldn't name another function with the same name as another important function that other people use. But it's not off limits, okay? So don't do silly things like naming your function range or something like that, but you can do that. All right, so here's this is from Think Python, and there's a section on kind of the art of naming your variables, right? And so as you write your programs and stuff, you want to try to think of good variable names. And this is actually a hard thing to do. And so, but you want to be able to read your program later and understand what the variable is without having to like scroll through all of your other things to try to, to see where it was created, and try to remember, to figure out what it actually represents, right? So an important thing is you should write variables that are clear and concise. Kind of the de facto language for programming is, your variable names should be in English, okay? And then, and it shouldn't contain special characters. And so while you are allowed to have kind of, these, the dots over the letters and stuff, and accents over letters and things like that, for foreign languages and stuff like that, it's best to just kind of stick to your standard ASCII keyboard. So whatever letters you see on the US keyboard, keep those as your variable names, okay? All right, and so here I have a few examples of bad variable names and alternatives that are better, right? So if you just say S is equal to 101533, we have no idea what this is, right? And I realized all of my examples earlier, because they were had no context, I was just using single letter variable names, okay? And it's very common to use single variable letter names, but it's not good practice when those variable names actually represent something, okay? Single variable letter names is maybe good for like placeholders for like matrices, like which row you're in, which column you're in, and things like that. But but something like that. Okay, SID. Okay, now we think like, okay, well, maybe this is some kind of identification number. Maybe this is a little bit better, but again, it's probably not enough to fully identify. Okay, unless like within your company, if this is an acronym that's like super well known, then sure, maybe this is useful, right? Okay, but the problem is that your general person reading this probably not going to represent, right? Okay. On the other hand, you can have a variable name like this. This is allowed, but it's just obviously way too long, right? Finnish Meteorological Institute observation station identification number. Too long, right? We do have tab completion, which will save you a lot of typing, and that's a nice feature. But again, I mean, this is just hard to read. It's hard on the eyes. Okay. So as far as naming conventions go, we generally recommend either snake case or camel case. Okay, snake case, sometimes also called pothole case. You basically separate your words using underscores. Okay, and I tend to use snake case. Okay, but camel case is also an option. All right, and that is you indicate new words using a capital letter. Okay, lower camel case just means the first letter is lowercase. Upper camel case just means the first letter is a capital letter. Okay, uppercase letter. All right, and so so here would be maybe a better name. Okay, FMI station ID. Okay, and then we go, okay, so now we have an idea of what this represents. Okay, so that's probably better. Okay, or FMI station ID written this way. Here are just a few more tips as far as naming things. Okay, if you have a list or an array, the name of your list or array, probably you should make it a plural name. Okay, because lists contain multiple things, arrays contain multiple things, right? So you can have an array called fruit containing apple, banana, and orange, but because you have multiple of these things, a better name would be fruits. Okay, fruits would be a better name versus just singular fruit here. Okay, and then if you do have string values inside your list, it's often useful to include the word names as part of the variable name. Okay, so here we can write fruit names. Fruit names would be apple, banana, orange, and this is a clear indicator that later on, when you are referring to something like fruit names, that the contents of fruit names is going to be some kind of string value. Okay, string valued objects, right? Because the whole idea here is just that as you're reading your code, just by looking at the name, your brain can say, oh, we probably have string values, character values somewhere in here. Okay. Boolean values, if you're going to have a variable store a Boolean value, it's going to be better if you change them into kind of almost like a question, right? A question that would be answered with a yes or no, right? So selected equals true is going to be better using the variable name is selected. Okay, right equals true. Maybe you can call it can write. Okay, can write true. Then you can say, oh, okay, we're going to use this thing, right? Fruit versus is has fruit equals true, right? And then so that way, when you're writing a script, you can just write if and then parentheses is selected colon and then the operation. Then it's just kind of, it just almost makes sense, right? If it is selected, do this, and if it's not selected, don't do it, right? Or if you can write, do this. If you can't write, don't do it. Okay, and so these almost make your commands almost like English readable, which is great. It looks like my lecture is going to run a little short today. Okay. All right, and then as far as numeric variables, right, using a describing word to the numeric variable can also be useful, right? So you can have rows equals 3, right? And perhaps a better a better variable name would be like the minimum number of rows, right? So if you're setting, you know, the width of the size of your matrix or something like that, you can say, you know, the minimum rows has to be this, or the maximum number of rows, or the total number of rows, or something like this, right? So total rows versus just rows equals 3, and then you have current row equal to 7, or something, something like that could be a better variable name for numeric values. Okay, and these are all just kind of like best practice tips, not necessarily like, it's not like your code is bad if you don't do this, but the idea is you want to make it, you want your code easily read. Okay, and just because probably the person who's going to be reading the code the most is going to be you, and you want to make your life easier and better by writing code that you can read and understand well later on. When it comes to naming functions, okay, you know, functions are basically the verbs, the actions that we can do in Python, all right? And so if your function is going to actually modify an object, the name of your function should be an action verb, right? And if the function is not going to modify an object, but it's going to return something like a new object that is a modified version of the object, then you can call give it a passive form of the verb, right? So here's a kind of an example is, so in Python, you can have objects like a list, and you can have take a function that will actually take the list and modify the list itself, okay? Right, and so for that, we would call that function sort, okay? Because it's going to take the list and it's going to actually sort the list itself, and the list is going to be modified. So we're going to just say sort the list, which kind of makes sense to you know, to tell somebody like, here's a stack of papers, I want you to sort them, okay? On the other hand, there's another function that takes the list, doesn't actually modify the list. It creates a copy of it, okay? And it presents back a sorted version of the list, right? So you get back a sorted version, and that's going to be called sorted, all right? So sorted is going to be something that returns a copy that is sorted, whereas sort is going to actually modify the list itself, okay? And so Python actually follows this. And so here is, here's a list that I've made called car brand names, and we've got Ford, BMW, Volvo, and Toyota. And here we can call sort, and this is actually going to modify the list itself. And so if I say, well, what is in car brand names, it's going to return the list itself has been sorted in alphabetical order. Okay. Here, I create another list with some brand names here, and there's a function here called sorted, and what this will do is it returns this, okay, but this does not actually modify the original list itself. So if I call later on, if I say, you know, what is car brand names, it remains in the original order here, okay. And the way we actually call these is a little bit different. We have this dot sort is a method of the list, and we'll get into all of this in a little bit later. We'll talk about lists and the methods associated with them. So dot sort is a method associated with lists, and then sorted is just kind of a function that can accept a list as an argument here. Okay, so so the original list here is unmodified, and if you try to run something like dot sorted, this attribute doesn't actually exist. If you try to run sort on here, this function doesn't exist. And so there's a few things that that Python, you know, in the naming of its own functions, it tried to preserve some of these best practice ideas as far as naming functions and going from there. Okay, are there any questions on this? This is all very basic stuff, an intro lecture, and we kind of went through it a little bit quick today, but I think that's all right just for your maybe your Monday lecture. I'm going to post your first homework assignment up tonight, and I'll also assign a few chapters from data camp. Okay, and so I'll make the data camp chapters we'll do Friday, and then and I'll make sure to give you at least a week to complete your first homework assignment, so that you can expect those to be posted up soon. But we'll just let you guys go a little bit early today. Okay, last view quiz answer for today is the letter B. The letter B as in bear. The letter B. All right, we'll end here for now, and so have a good evening. Be on the lookout for a couple new assignments, and we'll see you guys on Wednesday.